In triangle ABC, angle ABC equal angle ACB equals 60 degrees. Point D is any point of BC. Angle ADE equals to 30 degrees. DE perpendicular to AE. Point F is midpoint of DB. Connect EF and EB. Problem is how to prove EF equals to EB. In this video, I will solve this problem with 5 different solutions. You can make a try to solve this problem before watching this video. Maybe you can get more funny from this video. The first solution. Through point E, make a perpendicular segment EG to AD. Then, find midpoint H of FB. Connect GH. AG equals to 1/2 of AE. A equals to 1/2 of AD. So, we can calculate AG equals to 1/4 of AD. BH is also equal to 1/4 of BD. We get GH parallel to AB. So angle DHG is equal to angle ABC equals to 60 degrees. We can also get angle DEG is 60 degrees. So, 4 points. DGEH. In same circle. Connect the H. Angle DGE equals to 90 degrees. So angle EHF is equals to 180 degrees minus 90 degrees. Also is 90 degrees. We get EH perpendicular to BF. H is midpoint of BF. So BH equals to HF. So EH is perpendicular bisector of BF. We can get the result. EF equals to EB. The second solution. Because AED is a right triangle, we can make circle O as diameter of AD. Intersect BC at point I. Connect OC and OI. Then connect OF and OE. Firstly, we will prove triangle OIC congruent to triangle EOF. OI and OD. All are radius of circle. So OI equals to OD. We get angle OIC equals to angle ODI. Obviously, OF parallel to AB. So we can get angle OFB equals to 60 degrees. We can get equation for angle ODI. Obviously, angle AOE is also equal to 60 degrees. So get equation for angle EOF. We can calculate angle OIC equals to angle EOF. If we connect AI, we can get angle AIC also equal to 90 degrees because AD is diameter against point I. An equilateral triangle ABC. AI perpendicular to BC. So point I is midpoint of BC. So IC equals to 1/2 of AB. Obviously, OF parallel to AB also equals to 1/2 of AB. We can get IC equals to OF. Then OE equals to OI. We can get triangle OIC congruent to triangle EOF. So EF equals to OC. A equals to AO. AB equals to AC. These two angles are all 60 degrees. So angle EAB equals to angle OAC. From SAS theorem, triangle OAC congruent to triangle EAB. So we can get EB also equals to OC. Now we get the result. EF equals to EB. The third solution. Through segment BF, make another equilateral triangle FBJ. Connect DJ. Point F is midpoint of BD. FJ equals to the BF equals to FD. We can get angle BJD is 90 degrees. So triangle BJD is 30, 60, 90 degrees triangle. Triangle BJD. Similar to triangle AED. We get DJ over DB equals to D over DA. Connect DJ. Let's focus on triangle JDE and triangle BDA. We can calculate angle JDE equals to angle BDA. Because angle EDA equals to angle JDB. From SAS theorem, we get triangle JDE similar to triangle BDA. So angle DJ equals to angle DBA is also 60 degrees. We can calculate angle BJE is equal to 30 degrees. Because triangle BFJ is equilateral triangle. So angle BJF equals to 60 degrees. So angle FJ equals to angle BJE. Meanwhile FJ equals to BJ. EJ equals to EJ. So this two triangles congruent. We can get the result. EF equals to EB. The fourth solution. Let's find point K, the midpoint of AB. Connect EK. Extend EK to BC. Intersect BC on point L. Through point E. Make a perpendicular segment EM to BF. Let's focus on triangle EAK and triangle DAC. EA over AD is 1/2. Because triangle AED is 30, 60, 90 triangle. AK over AC also is 1/2. Because point K is midpoint of AB. So we get EA over AD equals to AK over AC. Because angle BAC and angle EAD are all 60 degrees. So angle EAK equals to angle DAC. So we can get triangle AEK similar to triangle ADC. We can get EK over CD is 1/2. And angle BKL also equals to 60 degrees. And angle BLE also equals to 60 degrees. Let's focus on triangle LME. Is a 30, 60, 90 degrees triangle. So, LM equals to 1/2 of LE. Triangle BLK is an equilateral triangle. The side ratio to triangle ABC is 1/2. So we get LK equals to BL is equal to 1/2 of BC. Segment BM equals to BL minus LM. Replace BL by BC and LM by LE. LE equals to LK plus EK. LK is also 1/2 of BC. EK is 1/2 of CD. From this equations, we can conclude BM equals to 1/4 of BC minus CD. BC minus CD is segment BD. So BM equals to 1/4 of BD. Point F is midpoint of BD. We can calculate MF is also 1/4 of BD. So BM equals to MF. Meanwhile, EM perpendicular to BF. So EM is a perpendicular bisector segment to BF. We can get the result. EF equals to EB. The fifth solution. Because triangle EAB is a 30, 60, 90 degrees triangle, we can make an equilateral triangle NAD as base of segment AD. Through point N, make a perpendicular segment to AD. Intersect DE on point P. So point P is the centroid point of equilateral triangle ADN. Because angle AND equals to angle ABD. So 4 points A and BD in same circle. Their center point is point P. Find point R. The midpoint of DE. Point S. The midpoint of EF. Connect PF and connect RF and RS. Intersect on point U. Find point T. Midpoint of PE. We can get P equals to 1/3 of DE. Because point P is centroid of equilateral triangle, AND. We can calculate segment ET equals to TP equals to PR is 1/6 times DE. Because point R and point S are midpoint of DE and EF. So we get RS parallel to DB. And point T is midpoint of PE. So TS parallel to PF. In triangle RST, TP equals to PR. So we get UR equals to US. Point P is center of circle. And point F is midpoint of DB. So PF perpendicular to DB from bisector chord theorem. So PF also perpendicular to RS. UR equals to US. So we get PF is the bisector perpendicular segment to RS. We can get RF equals to SF equals to 1/2 of EF. In triangle DEB, because point R and point F are midpoint of DE and DB. So segment RF is also equal to 1/2 of EB. We can get the result from this 2 equation. EF equals to EB. I am just find 5 solutions to solve this problem. If you find something new, or have any ideas for this problem, please feel free to comment and leave a message to me. Thank you very much. Please don't forget to thumbs up and click the subscribe button if you don't subscribe my channel now. Turn the bell on. You will not miss my future videos. See you next time.